Imagine strolling outside on a perfect sunny day. Suddenly, everything peaks with anticipation. You look above, and there is a purple alien repeating, "I am from planet Dixirect." If only there was something to stop an alien invasion. Oh, wait, there is. Introducing trigonometry. Trigonometry has a number of functions, so before we get into saving the world, let's get into some of the rules. Trigonometry alludes to estimations of triangles, which is the place the trie originates from. Right-angle trigonometry consists of ratios of sine, cosine, and tangent rules. The mnemonic Socator can be used to memorize this. To view an example of this, please refer to Part A or later on in this video. The angle of elevation is where the angle goes above the horizontal, while the angle of depression is where the angle goes underneath the horizontal. A compass bearing is where a direction is given off by presenting either side of north, south, east, or west, including the degree. For instance, south 30 degrees east, while a true bearing is where a course is given by estimating the edge clockwise from north to the required direction. For example, 120 degrees true. To refer to an example of this, please refer to Part A. The territory of a triangle is a large portion of the result of different sides duplicated by the sine of the point between the different sides. This is further emphasized with the following equation. The sine rule relates to the sides and angles in a triangle. It states that side A divided by the sine of angle A is equal to side B divided by the sine of angle B. This is represented by the following equation. To view an example of this, please refer to Part A. Note that through this equation, both the angle and the sides can be calculated. The cosine rule is a formula that uses different sides and the angle inverse the side that is unknown, which can be utilized to locate the obscure side. This is presented by the following equation. The cosine rule can also utilize three unknown sides to find the angle opposite of a side. This is further encompassed in the equation provided. Thus, trigonometry can be utilized in astronomy. Astronomy is a part of science that manages celestial items, space, and the universe in general. In spite of the fact that trigonometry can be connected in numerous professions and areas, for example science and building, its principal use is related with space science. In space science, trigonometry is frequently used to discover distances to nearby stars and other celestial objects, using a strategy of a parallax. A parallax can be characterized as the evident move of a close-by star against the fixed foundation that can be seen as the Earth circles the Sun. Despite the fact that astronomy has been in presence for a great amount of years, it is only recently that trigonometry and space science have collaborated. For example, a nearby item viewed from two different positions will seem to move, as for an increasingly different foundation. This change is known as a parallax. By measuring the amount of shift in the object's position from a baseline, the distance to the object can be calculated. For instance, in the diagram provided, the situation of a star is estimated when the Earth is at position A. The estimation between the Earth and the Sun is known as 1 astronomical unit. In the event that the appreciating angle of the baseline to the star is known, then the unknown side, the distance of the Earth to the star, and the distance of the star to the Sun, can be found as it forms a triangle. Furthermore, looking at a real-life example, the following example provided can be calculated. We know that the distance between the Sun and the Earth is 1 astronomical unit, and in this case, the appreciating angle in angle ABC is 60 degrees. We are trying to find the distance, and so the side opposite the angle. We equip the tangent function, as we know the adjacent and the angle. Once we rearrange this equation, we now know that distance equals to tan 60 times 1 astronomical unit. Tan 60 is equivalent to the square root of 3, and so the answer to the distance of the star and the Sun is distance equals to 1 astronomical unit times the square root of 3. Similarly, other right-angled trigonometric rules can be utilized to calculate other unknown angles and sides of this very example. Along these lines, trigonometric proportions can be used to find the separations of stars and planets as well from the Earth. This can at last enable space experts to foresee potential interruptions and to improve logical comprehension of the idea of reality by watching the impacts of extraordinary conditions, just as to see how to colonize different planets if necessary to. Trigonometry can likewise be used to further understand how life started on this planet. In conclusion, trigonometric rules and mathematical calculations are utilized in many careers and areas, such as chemistry, physics, and engineering. It also assists with astronomy and prevents the danger of unknown disturbances. It also assists with astronomy and prevents the danger of unknown disturbances such as meteorites and aliens from invading our planet. Thanks for watching!